Now we've cut the cone. See how it looks, sir. This would look something like this from the top. Again an ellipse, something of this sort. That is the sectional side view. Now let me tell you very honestly, if you can make this drawing on a plain sheet of paper, you are guaranteed 7 marks out of 10. But sir, why are you cutting our marks? If you can make this diagram, you are going to get at least 8 marks out of 10. This looks like a very professional drawing, and that is exactly what I expect all of you to create on a plain sheet of paper. Good evening, students. This is Manas, your friend and tutor, and in today's session we have got a cone with us. Okay, and we are going to cut this cone. We are going to make the front view, the sectional top view, the sectional side view, and the true shape of the section. All of this and much more is going to be very interesting. So I want all of you to watch this video. Stay with me right till the end. You will be benefited. That is for sure. If you don't know anything about section of solids, by the end of the video, let me tell you, you will have an edge over the others. That's a guarantee. Okay, now everything initially I'll be explaining with the help of this 3D environment in AutoCAD. You will see the cutting action happen real time. You're going to see everything in 3D, the front, top and side views. So it's going to be fun. I think it's better that we read the problem initially. Here we go. Let me zoom in and let me read this very carefully. Okay, a cone base 75 mm diameter and axis 80 mm long is resting with its base on HP. Important dimensions related to a cone. Circular base, the diameter is 75. That means the radius is going to be half of it. That is 37.5. That's for sure. Secondly, sir, the length of the axis has been given as 80 millimeters, 80. It is resting with its base on HP. So the base is circular. Okay, resting on HP. Done, sir. It is cut by a section plane perpendicular to the VP. So you can consider my tablet, okay, to be a section plane. Right now it is parallel to HP. Okay, but it is here. You've got the vertical plane, or you consider my body as the vertical plane. So it is perpendicular to the VP. Now it could be making some angle with the VP, HP also. If you read carefully, this section plane being perpendicular to the VP simultaneously creates 45-degree angle with the HP. So it is going to be something of this sort, and we are going to be implementing these things. One more thing to notice is when you create the front view, you guys are looking at it from the front, you won't be able to see this plane surface. Rather, what you will see is an edge view of the plane. Okay, and I'll prove it to you, don't worry. Now this plane cuts the axis at a distance of 35 mm from the apex. Apex happens to be the topmost point of the cone. We need to create the front view, the sectional top view, sectional side view, and the true shape of the section. Now let's look at it from the 3D perspective. And first of all, this is the cutting plane. When you are going to look at this cutting plane from the front, sir, it would look like an edge. You can clearly see this. Now let me bring this cutting plane downwards and let's cut the cone. Okay, let's have some fun. 1 2 3 4 5 6 7. Okay, interesting. Now we've cut the cone. See how it looks, sir. The section is in the form of an ellipse. So in the sectional top view there will be an ellipse, in the sectional side view there will also be an ellipse, and the true shape obviously has to be an ellipse. Okay, the true shape really. Now if you want to take a look at it from the front, here it is. This would look something like this from the top. Again an ellipse. Sir, if you can show that front view again. Yes, here is the front view. Sir, we also have to make the sectional side view. Let us take a look at it from the left hand side, and from the left hand side we can actually see this section, and it would look something of this sort. That is the sectional side view. So these are essentially how the views would look, and you guys have to make this on a plain piece of paper. You can also use AutoCAD. Okay, if you have got a computer, use AutoCAD. If you don't have, make this entire thing which I'm about to implement on your paper. Okay, I think we rather should go for it. Here we go. Where is my PowerPoint presentation? So the first thing to do is to make an XY lines. Wonderful, sir. Okay, just follow the steps. This is going to be easy. It is going to be over in the next 10 minutes. Follow the steps very carefully. Sir, if it is resting on the base, if it it is resting with its base on HP, the cone. The true shape of the base is visible from the top, and that's why we have to start by making the top view first. In the top view, we are going to see the circular base. Okay, that's the circular base. Now please note that this base is going to have a radius of, the diameter we know very well, it is 75. So radius is going to be half of that, 37.5. By the end of the video, I'll be doing all the dimensions, don't worry. But for now, I'm avoiding the dimensions. Okay, take some space. How much is this? Sir, radius is 37.5. Go for 4 parts. Okay, so this is very easy. Then go for 8 parts. You can see all of these 4 parts. Bisect all the 4 parts. You are going to eventually end up with 8 parts. Done, sir. Do the numbering. Okay, these are the bottom points of the generators. One sec. 1, 2, 3, 4, 5, 6, 7, 8, and this is the topmost point of the cone. What is that? That is what you call the apex. Done, sir. Now what? Now let us take a look at this cone from the front, from here. Here it is. Okay, sir, this point is 0.1. This is going to be 0.2 dash comma 8 dash. Sir, this is going to be 0.3 dash comma 7 dash. That's 4 dash comma 6 dash, and that's 5 dash. Now give the height of the cone. Sir, height has been given as 80. Okay, again, this is 80, sir. Right? So at a height of 80, you have to mark this apex. And now you can, this is the bottom point of the generator. You can connect 1 dash with O dash, 2 dash with O dash, 8 dash with O dash. Although 2 dash O dash and 8 dash O dash, both of them are going to overlap. So there is only one generator. Please note, there is only one generator, but there are 2 generators over here. There are 2 generators, one generator. Okay, sir. Now what? Pick your mini drafter or your roller scale. What you now need to do is mark a point. Yeah, sir. How far is this point? So this point essentially is at a distance of 35 millimeters below the apex. Have you marked this point? Yes, sir, we have. Okay, so you can make a reference line also. It should be very, very light. Keep it light. Okay, you can keep your protractor over here, and at an angle of 45 degrees, you can create a line. If you have got access to a mini drafter, then what you can do is you can rotate the mini drafter at an angle of 45 degrees, bring it over here, very close to this point, and then you make a line like this. Wonderful, isn't it? So the cutting plane has been done. Now, one thing that you all must notice, that between these 2 points, the part of the cutting plane is thin. Okay, it is a dash dot line, but it is thin. But beyond the cone, to the left and to the right, it is thick and dark. Dash dot, thick, dark, dash dot, thin and dark. So make sure you follow this protocol while making the cutting planes. Done, sir. Now you need to mark the points. How many generators do you have over here? Sir, there is only one generator. That means there is going to be only one cutting point, and let's name it as A dash. Sir, here this O dash and 2 dash, and then there is O dash and 8 dash. So there are essentially 2 generators. So they correspond to 2 points. Similarly, 2 points, and there is going to be 1 point. Okay, sir. Now what? Now you need to mark all of these cutting points on the top view also. So this O dash has got this point A dash. Okay, now take a look at this point, bring it downwards. Okay, O dash 1 dash has got this point A dash. Similarly, O1 will have this point as A. This is how you need to repeatedly keep on marking points. Similarly, here O dash 2 dash has got B dash, so I can bring this point in the downward direction. O2 is going to have this point, is going to be called as B. Similarly, there is going to be one more point, because there are 2 generators, not one. One point is going to be in front, while the other point is going to be exactly behind. So C is going to be exactly behind B. One thing that you should notice, whatever I write at the top of the cutting plane, that appears first when looking from here. So when you look at it from over here, you're going to see B first. That is why B at the top. Okay, C is behind B, so C is behind B, below B in the front view. This is how I do the cutting. Okay, what else? Sir, what about this D and E? There is a problem. When you observe this point, you've marked the point, okay, you know very well that D dash is going to lie in O3 and this E point is going to lie in O7 in the top view. But the moment you draw a line, it actually overlaps with the generator O7 and also with the generator O3. So how do you fit this? What you can do is you need to rotate the cone, by the way. Okay, you can shift this point towards the right hand side, make an absolutely horizontal line and then bring it downwards. Yeah, done. Now you need to make use of a compass. Keep steel end of your compass at this spot, pencil end at this spot, then rotate anti-clockwise, mark an arc, then rotate clockwise, put an arc again. These 2 points are essentially, this is going to be point D dash D and this is going to be point E. Okay, let me do this. Easy. What about sir F and G? This is very easy. F is a point on O4 whereas G is a point on O6. So bring them in the downwards, project it downwards. So here this is point F and here this is point G. Done. Similarly, you can have point H. It's a single point on a single generator. Get it downwards, that's point H. So far so good, but again there is a problem. What is the problem? So we can observe that we can actually make an ellipse like this, sir. But this does not look like a perfect ellipse, sir, because we know very well in an ellipse we actually make this major and minor axis initially. Sir, we can clearly see the major axis. What is the major axis? It is AH. But sir, for the minor axis, you don't have any extreme points. Can you devise a method or can you propose something with which help we can make the minor axis or we can clearly have a width of the ellipse in our mind? I surely can't do that. Take a look at these 2 points. I want all of you to focus between these 2 points and the portion of the cutting plane between these 2 points. You need to find the midpoint of these 2 points. Well, the midpoint is going to be somewhere here. Okay, I think I better use a different color. Where is the black color? Okay, that's the midpoint. That's the midpoint. Can you find the midpoint? What you can do is keep one leg of your compass over here, other leg somewhere here. Okay, more than half of this distance. Then you need to put 2 arcs using A dash as center, and then you need to cut these 2 arcs using H dash as center. Okay, it is these 2 points that you need to join and you are going to have a perpendicular bisector of a line. This is what I want all of you to do, and you are going to have a point over here. Once you've got M dash and N dash, connect with O dash and make sure the line passes through them and it actually connects with the bottommost point on the cone in the front. So this is how it would look. Okay, now these 2 points are extremely close to each other, extremely close. Bring it downwards. It is going to cut the circular base at 2 spots, one over here, one over here. Let's say so this is 9 dash and 10 dash. Let's say this is going to be 9 and this is going to be 10. Can I do this? So I have got 2 more generators from 9 to O and from 10 to O, 10 to O and 9 to O. Done. Okay, now you can easily mark these 2 points M and N in the top view. You just need to project it in the downward direction. Here you are going to get N, here you are going to get M. Done. Done, sir. Now you can successfully create an ellipse. Rather I should say you will be able to create the sectional top view. So join all of these points in proper sequence with the help of a smooth curve. I would suggest all of you use your right hand if you're righty, or a left hand if you're lefty. Keep your hand very, very steady. Okay, your forearm should be resting very properly on the table, and then it is with the help of the wrist you can make this one go, then another go, at least maximum 3 rounds. You can make the entire ellipse. Let me make it in one go. Wonderful. Do the hatching. Done, sir. Easy. Okay. Sectional top view. You can see the section over here, and this is the top view. That's why we call it the sectional top view. In short, we write it as STV. I'm going to be writing all of those things, don't worry. Now we need to create the side view. We need to take a look as to how this looks from the side, left hand side to be very precise. So let me make another plane. Okay, and this is where I'm going to create the LHSV, that is left hand side view. Very, very interesting. This could be any distance, by the way, don't worry. Okay, project the lines through all of these numbers and through all of these alphabets. One sec. Erase. Now project the lines through all of these numbers and through all of these alphabets. You should not miss any point. Let me tell you very honestly. Here it is. And by the way, this angle is 45 degrees. Okay, now project horizontal lines through all of these points and through all of these points. I mean, you don't have to worry about all of these points because you can see this horizontal line. Okay, even if you make one, it is going to overlap. So we are going to do this with the help of a mini drafter. That is something that I would propose. Do it, and then project these points upwards. It is the intersection points that we are interested in. Okay, now listen. O dash, that's the line for O dash. This is O, 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 and this point has got to be, sir, O double dash. Why double dash? Because it's a side view, sir. Okay, let me give you one more example. Let's say you want to locate H. Sir, that's H, H. This is the line for H. H has got to be somewhere on this horizontal line. So take a look at this from the top. Sir, this is the top view. H, 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 H. So the two lines intersect over here, and this point has got to be H double dash. Done. In the same fashion, you can work out this point D also. For example, let's say you want to locate D. D, 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 D. Where is D over here? My goodness. D, M and B, they happen to be so close. There are three lines. Oh, I'm unable to see this. This is point D, the topmost line. Okay, these three lines and the topmost line is what we are focusing on. The leftmost line now. Leftmost line. This is going to be point D, double dash. Okay, now please follow the steps and mark the remaining points. This is going to be very helpful. Now when you look at it from the side, these are the generators, extreme generators from 7 to O and from 3 to O. So from 7 to O double dash and from 3 to O double dash, this is what you need to join. First of all, just do it, and then you can join all of these points in proper sequence. You're going to end up making a curve, and this curve is popularly known as an ellipse. Okay, where that's the major, that's the minor axis. You know this. Done. Do the sectioning, hatching. Whenever you do the hatching, the spacing has to be 3 millimeters. That is what I would suggest. If the drawing is a bit big, then you can fine tune your spacing. Okay, fine, sir. And all of this can be done very easily with the help of a mini drafter. I suggest you all to use a drafter as much as possible. It is going to make your task very, very easy. Done, sir. Now what? Now comes the part where we are going to create the true shape. For making the true shape, let me have an auxiliary plane which is parallel to this cutting plane over here. Now again, you've got to make use of a mini drafter. Please keep your mini drafters, one scale of your mini drafter along this cutting plane. Done. And then lock your mini drafter. Locked. Okay, sir. Then bring your mini drafter at A, draw a line. Then get your mini drafter to B dash and C dash, draw a line. Keep on repeating this process unless all the points have been exhausted. Done, sir. Okay, now let me demonstrate how to get all of these points, the points on the ellipse, on the outline, on the true shape. This is going to be fun. So let's say we want to mark A. Keep one leg of your compass at this very point. Steel end, the pencil end over here, let's say, and with that much as the radius. Okay, please just do not disturb the compass. And take a look. Please follow the path. This is the path, then this is the path. So we've taken the arc with respect to xy. We are going to put the arc with respect to x1, y1. So this is going to be the center. Mark. That's A dash. Not A dash, that's A basically. Okay. Let me explain once more. Let's go for B. Sir, that's point B. So keep one leg of your compass on xy, other leg at B. Now this has got to be absolutely perpendicular with that much as the radius. Now follow the path b b b b b, and then with respect to x1 y1, cut an arc again, that is b. Okay, in the same fashion you can get point C also. This is going to be that arc, this much as the radius, and then with this as the center, cut an arc, that's point C. In the same fashion you can obtain the remaining points M, N, D, E, F, G, H, and pass a smooth curve through all of these points. What you are going to have is a beautiful ellipse. Okay, and do the hatching. It is going to look something like this. Wonderful. That is the drawing. Now let me tell you very honestly, if you can make this drawing on a plain sheet of paper, you are guaranteed 7 marks out of 10. But sir, why are you cutting our marks? Where are these 3 marks going? The problem is I have not put up the dimensions, and I also have not shown which portion of the cone is remaining and which portion has been chipped off or cut off. Now take a look. If you can make this diagram, you are going to get at least 8 marks out of 10. Again, I'll explain why 2 marks have been cut. Now dimensions, okay, you have placed the dimensions beautifully. You've also shown that this outline is dark. Here you can see, since this is the remaining portion, so this has been darkened, this has been darkened, this has been darkened. So due respect has been given to the portions of the cone which are remaining, which are left, and this portion you have to keep it light. Is it really looking light? This is the construction, sir. This is the construction. Is it really looking light? No. Now see, is it looking light now? Yes sir, it is. This looks like a very professional drawing, and that is exactly what I expect all of you to create on a plain sheet of paper. Okay, that's the standard, that's the benchmark. Please note, these construction lines should be done with the help of a 3H pencils. These outlines, these are going to be thick, and let me write thin over here. Okay, and these have to be done with the help of an H pencil. Okay, you just need 2 pencils. In fact, I can create the entire drawing using an H pencil. I'm going to press hard where I need thicker lines, darker lines, and I'm going to keep it very gentle, very soft. I'm going to hold it where I need, I mean the shades to be close to 3H pencil. Okay, 1 single pencil also can do the job. It's your skill then, right? How many minutes? Almost 22 minutes. So guys, that was all from my side for today. If you find this content to be helpful, do write down in the comments to let me know what you think about it. And if you really appreciate the content, do like the video and share it with all your friends and classmates so that they can also benefit. This is Manas Patnaik signing off. Take care and have a nice day. Thank you very much.